Hi, here we have another exercise from Iranian Mathematical Olympiad, round 1, 1997. Let's look at the question. For which value of n the following equation has a unique answer in natural number? So 1 over x minus 1 over y is equal 1 over n. All of these are members of natural number, and we want to see for which value of n we have a unique answer. So these are the answers. Typically, in the first round of Mathematical Olympiad in Iran, you get 30 questions with 3 hours. So each question you have approximately 6 minutes. So you can spend between 5 to 10 minutes and see if you can solve this exercise. To my view, this exercise was among the more difficult questions in that exam. All right, let's look at the solution. Here is the equation. I take the left side and I take common denominator here. So this would be y minus x divided by xy. So here what we can do is that we can take this y minus x to this side. So basically 1 over y minus x times this is equal 1 over xy. And we can spread this one into each term. We get 1 over x times y minus x minus 1 over y times y minus x is equal 1 over xy. Here we notice that if n is written as xy, and if xy are not equal, we can actually write n in this format. We can also consider special cases. For example, let's assume x is equal to 1 and y is equal to n. What happens in this case? So obviously this is 1, this is n minus 1. We get this one. This is n, this is n minus 1, we get this one. So for any number n, we actually can find x and y that fulfills this equation. So we already found one solution for this equation. But this does not help us because the question asks for which value of n we have a unique answer. We don't know whether this is a unique answer or not. We know that this is one solution. Okay, so now in order to answer that question, first thing that came in my mind was that, okay, so here I saw we can write 1 over xy as this combination. So then I thought that maybe I should consider n is a composite number of, for example, n is equal a times b, and then try to see what I can achieve. So here is our equation, and now I assume n is equal a times b. So obviously y minus x divided by xy will be 1 over ab. And we do this one multiply this is equal this one multiply to that. So y minus x times ab is equal xy. Now here we have to be a little bit creative. We know that ab is n, and this is actually something that is given to us. We cannot change it with this assumption, obviously. xy is the solution of the equation. So xy can be actually anything as long as it fulfills this equation. Here, I want to be creative and I considered y is equal ab times another number, y prime. Of course, I considered this because I know that if I do it, then ab from both sides will be simplified. Maybe you could say why you consider this. This is the choice that I made so that I can simplify the equation because x and y are the solutions and we are searching for a way to find these solutions. But of course, with this equation, we cannot directly find the solution. So we have to be a little bit creative to see what we can achieve. Okay, so I assume y is equal ab multiply y prime. And in this case, we just replace y with this ab y prime minus x times ab is equal x times ab y prime. ab with ab simplifies and we get to this equation. So now we can move the x to the other side, we get to this and we can factorize x. We will have this one. But we know that y prime and y prime plus 1, they are prime with respect to each other. So they don't have any common divisors. In this case, it means that x must contain the whole y prime because x is in the right side, y prime is in the left side, and this other number is prime with respect to y prime. This means I can write x as y prime multiplied to x prime. And then I can replace this. So instead of x, I put y prime multiply x prime. And obviously y prime with this disappears. we get to this equation. AB is equal x prime time y prime plus 1. All right, so we get to this point, and now I can just assume values for x prime and y prime so that this equation is valid. For example, if I say x prime is equal a, then y prime plus 1 will become b, so y prime will be b minus 1. In that case, I can reconstruct x, which we considered it as y prime times x prime. So x prime is a, y prime is b minus 1. So we get to this one. And y, we assumed it to be ab times y prime. So it would be ab times b minus 1. And obviously, if I put these values in the main equation, so 1 over x minus 1 over y, you take the common denominator. So AB, B minus 1, here will be B minus 1, this with this disappear is 1 over AB. So this is our N, which is a composite number, and we found one solution for this composite number, N equal AB. Now here we can also assume different combinations. For example, let's assume x prime is equal to 1, and in this case, y prime will be AB minus 1. And again, we can reconstruct x and y. So this is y prime times x prime. This is 1. This is ab minus 1. And y is ab y prime. So it's ab minus 1. Now, if you put these values into the main equation, 1 over x minus 1 over y. So this is 1 over ab minus 1 minus 1 over ab times ab minus 1. Again, if you take common denominator, denominator becomes ab minus 1. This with this disappears. It becomes 1 over AB. So for n equal to AB, we found another solution which also fulfills the main equation. We can now conclude that if n is a composite number, can be written as AB, then we already have two solutions. Of course, in this case, I assume that A and B are both larger than 1, because otherwise here we will get 0. So for any composite number, we found two solutions. At this stage, you can actually go back to the options and you can immediately eliminate all the options because all of them are composite. So the answer would be none of the options. But let us prove that if the number is a prime number, we will have a unique answer. So in this case, we have the main equation and we assume n is a prime number. So if n is prime number, we can replace it. Y minus x divided by xy is 1 over p. Same way, we multiply this to this to this. Because p is prime, p must be either inside x or must be inside y. Now let us assume that p is a divisor of x. So we can write x is equal to p times x prime. And we replace it into this equation. So y minus p x prime times p is equal to p x prime times y. P with p disappears. We get to this equation and we can now rearrange it. So y times 1 minus x prime. So this one comes to the left side. This one goes to the right side. We get to this equation. Obviously, this equation does not have an answer in natural number because x prime is 1 or larger than 1. So this will be either 0 or a negative number, but the right side is a positive number. So this actually is not a solution. This is wrong. This means our assumption that x is equal p times x prime cannot be correct. Okay, so now we can consider the other possibility, and that is y is equal p times y prime. We can replace it into the equation. P times y prime minus x times p is equal to x times p y prime. P with p disappears. And then we simplify this, take this on the other side, factorize x. We get to this equation. Here again, we know that y prime and y prime plus 1, they are prime with respect to each other. That means x must be equal to y prime times x prime. These are all first. We replace it. Instead of x, we put y prime times x prime. And now we see that y prime with this disappears. We get to this equation. This is very similar to what we got before, with the difference that here on the left side, we have a prime number. Okay, because this is a prime number, we know that The factors are 1 and p. Since this one is larger than 1, we know that x prime has to be 1 and y prime becomes p minus 1. And we can reconstruct x and y. So x is y prime times x prime. Okay, so this one is p minus 1 because this is 1. And y is p times y prime, so p times p minus 1. And if we put these into the equation, 1 over x minus 1 over y becomes this one, which is equal to 1 over p. And this is the only solution because every choice that we had was forced. And obviously this is very similar to the original solution that we found. When p is a prime number, then this is the only solution. Now if we look at the options, obviously 1024 is a composite number. 2119 is also a composite number, 13 times 163. This one is a composite, and this one also is a composite number. So the correct answer is none of the options. Okay, so we have learned a few techniques or ideas. First one is to investigate the different ways a number can be written. For example, consider if it is a prime or is a composite number and evaluate what happens under each scenario. The second one is to be creative, and if an equation can have many solutions, consider some of them and proceed and try to find a useful pattern. So sometimes you face with scenarios that have many solutions, but you can only see one of them. So try that one and proceed. Maybe that results in a useful idea later. These are basic facts about number theory. If p is prime and p is xy, either x is 1, y is p, or y is p, x is 1. And if p is a prime number and we have p times m is equal xy, either x can be written as p times x prime or y can be written as p times y prime. Alright, so that is the end of this video. See you next time. Bye.